putting everything together. Some vocabulary, some terminology, stuff you should be aware. We call each of these skeleton equations. This is called a skeleton equation because it may or may not be balanced. It shows you your reactants, it shows you your products, and the subscripts are right. So that 2 is correct, that 2 is correct, that 2 and that 3 are correct. But maybe the actual number of each element is not correct. So a skeleton equation is unbalanced, then you have the balanced equation. Oh, and this one, Tyra, we called a word equation because it's got the words. Some of these were balanced already, some of these were not. Let's find out. So until you get good at these, I generally make a list in my mind. I draw a little line to show left and right. You can draw that or you can just visualize it. Cam, you with me? Yeah. Okay, you're not looking at your phone or anything silly like that? Oh, okay, a poppy. Uh-huh. How many Ag is silver? How many silvers on the left? How many sulfurs on the left? How many silvers on the right? Yes. How many sulfurs on the right? Okay, now here's what I can't do. I can't add subscripts. That's wrong. You've just changed the whole chemical composition of what we're doing. What we are allowed to add are coefficients, numbers in front. Hey, how can I balance this, Cam, my friend? Right there. 2 marks each. If you got that, 2 out of 2. Otherwise, what I would do is I would give you 1 mark for the left side being right, 1 mark for the right side being right, which means don't add anything to the right side. They get tougher. Sometimes they're easier. Zinc plus S. You know what? Is that right? Balanced already or not? Yep. Okay, cool. That's a fairly, by the way, what that probably also tells you, that's a very simple chemical reaction. Yeah, for just not changing anything? Sure. What if you had tried to balance and you had done something like this? What did we say if you can reduce the coefficients? You always put them in lowest terms, right? So don't do that. Let's see, next one. This doesn't look balanced. So, okay, I got 1H, 1Cl, 1O. Now remember, these guys, Mr. Hofbrinkel, these tell you which of the elements when they're by themselves will always have a subscript of 2. The reason this says O2 is because it belongs to this list. Which ones are on this list? Remember, Matt, we got hydrogen, oxygen, fluorine, bromine, iodine or iodine, depending on whether you're British or American, nitrogen and chlorine. All of those, if they're by themselves, you can't just write them. You always have a subscript of 2 because they're so electron hungry, they'll bond with themselves. Yeah. What if you put the HCl all together as 1? If you get the same answer, fine. You might be able to. That might even be more cleverer. In other words, you said, Mr. Dueck, that's an HCl. I can treat that as 1 funky atom. That might get you there even better. Let's find out. 1H, 1Cl, 2 O's. How can we balance this? Well, right now what's unbalanced is oxygen. I got 2 on the right. I got 1 on the left. I put a 2 there. Courtney, did you do that? No. Then you're good. Is that it? Yeah, that's balanced? Oh, I guess I can go 2, 2, 2, 2, 2. Number 4. Okay. I got 1 Ca. I got 1 C. I got 3 O's. I have a feeling this... Oh, wait a minute. Is this one balanced already? I think so, because look, I got 1 Ca, I got 1 C, and although they're separate, I do have 3 O's, right? Now, if you didn't notice that it was balanced, you probably have the same number here and here and here and could go divide, divide, divide and reduce it to straight ones all the way across. This one's not balanced, and this one looks like it might be a little yuckier. 1 Al, 1 S, 2 Als, aluminums, 3 S's. Oh, this isn't too bad, actually, because I can get 3 sulfurs by doing that, and I can get 2 aluminums by doing that, and I'm done. Yeah? Yeah. Oh, phew. Now, Courtney, I loved your earlier suggestion about maybe I might keep those guys together, maybe. Although I got O's there and there, maybe I want to do them all separate. I don't know. I think I'll try doing them. This one looks a little ugly. Is 6 tough, or does it work okay? Anybody get 6? Think you got it? Okay, let's try. Give it a try. Here we go. I got nah. I got H. I got C. I got O. Okay, on the right-hand side, I got, oh, careful. How many C's do I have on the right-hand side? 2. How many H's do I have? 2. And how many O's do I have? 5, 6. 6? Okay, at least everything kind of looks like nice numbers. If I had 5 O's, I would have been going, ugh. By the way, you may notice if you have prime numbers, it's tougher to make these work because less numbers go into primes. All right, what should I start with? Suggestions? Nah. Yeah, I mean, yeah. Not nah. Okay. So definitely I can do that by doing that. Okay, that's going to domino Julie all the way through. That's going to give me 2 of those. And that's going to give me 2 of those, and that's going to give me 6 of those. Oh! Holy smokes! Is that it?
Yeah.
Oh, I thought that was going to be so much uglier because I have the O's everywhere, but that worked well. Yeah. So you have a 4 here? Do you have a 2 here? A 4 and a 4 and a 4? So show me it later, lawyer with me later, but right now I think you zigged. HgO2. There's 1 Hg. There's 1 O. Oh, this is Z. Oh, maybe not. 1 Hg. Oh, this isn't. Oh, yeah. I guess I need 2 of those, which also gives me 2 of those, so I need 2 of those. Do you get 2 HgO? Results in 2 mercury oxides. Results in 2 mercuries plus 1 O2 molecule. I think I can make these a bit bigger so you guys at the back can see. Number 8, balanced, yeah? By the way, what is NaCl? Sodium chloride. What is it in real life? Yeah, table salt. Okay. Now, Courtney spotted, perhaps I stole this from online. Courtney is saying, actually, Mr. Dueck, there's a mistake in the skeleton formula. The skeleton formula should have a 2 there. Now, the fact that the document that I grabbed this from does not means it's my mistake or wherever. I can't remember where I yoinked this from. I will fix it on my original. But if you did that and then you said, hey, it has to be that, and is that what you said? Mm-hmm. I'm impressed. Split 1 between incoming. Each have a piece. I'll have to fix that on the weekend. I got number 9 is the Hofbrinkel thing. I got H2 and I got O2. So, all right. Can you do these without writing everything out? Yeah. Would I do it on a test or a quiz that way, Sage? No. Will I try and do it that way in my homework to get expert at this? So I'm going to try and do this without writing stuff out. I'm going to say, okay, I need 2 there, because that gives me 2 oxygens to match those 2 oxygens. And I think, is that it? That gives me 4 and 2, 4 and 2. I hope. Put it face down in the appropriate block there again? Yep. You did? Thank you, sir. By the way, this is a typo. This 2 is supposed to be a little subscript. Sorry, I'll fix that on my original as well. 2 of those. Okay, this one's going to take more steps. I'm going to write this one out. Na equals 1, O equals 2, Na equals 2, O equals 1. So my first thought is to say I need 2 of those. That's great. And then my next thought is to say I need 2 of those. That's great. But whoops, that gives me 4 of those. Ha! I don't need 2 of those after all. I need a 4 right there. Is that right? Is it 4 NAs plus 1 O2 gives 2 Na2Os? Yeah. Nearly there. NH3 plus HCl. HCl, by the way, is hydrochloric acid. What was NH3? That's a polyatomic ion on the back of your periodic table, the positive one, isn't it? Or is that NH4? I think it's NH3. Oh, it's NH4. I take that back. Okay. This is going to yield that there. Okay. Oh, is this balanced already? It looked ugly, but it turned out to be not too bad. Turn the page. Okay, right now what's unbalanced are the oxygens. How many do I have on the left? 3. How many on the right? Have you guys learned what one of the tricks is? You kind of ask, what number can I turn a 3 and a 2 into that they both go, I think I'm going to turn them into 6. And the quick way is you can always try timesing them together. That's not always the best way, but that'll often get you there. So I guess I want to try putting a 2 there. That's going to give me 2 of those and 2 of those. And I'm going to try putting a 3 there. That's going to give me 6 of those. Oh, and 6 of those. Oh. And I guess a 2 there, is it 2 ClO3s yields 2 KClO3s? That sounds like a radio station. Yields 2 KCl's plus 3 O2s? Okay. This one might be yucky. Let's see. 1 N, 3 O's. 1 N, 2 O's. I guess I can somehow maybe sort of try and get 6 out of here. Okay, so let's try putting a 3 there. That gives me 6. That gives me 3. Oh, if I put a 2 there and a... No, that's not going to work. Yo. I can just put a 2 in front of the first NO? She says so casually. Like, you're saying that does it? Yeah. Let's see. That gives me 2. That gives me 4. Oh, and a 2 there? Yeah, I was going to find that. Honest. Last one with the skeleton, and then we got to go word, and that's why we need the periodic table. Fe plus O2, okay, let's see. 1 Fe, 2 O's, 2 irons, 3 oxygens. Okay, suggestions. Well, I guess for starters, I could try going maybe put a 2 there. You got the irons balanced. Well, oxygens, I got 2 on the left, 3 on the right. Cam, you pulled this one out earlier. What do I want to turn 2 on the left and 3 on the right into? Okay, so you're saying put a 3 there and put a 2 there. You know what? That gives me 4 irons. You know, I should have done the oxygens first. I need 4 of them there. Is it 4 Fe's plus 3 O2s yield 2 iron oxides? Words. Words. Well, this isn't too bad. I know Fe, I know S, because that's not a compound. But iron 2 sulfide, to get the correct formula here, I have to, Alex, my friend, crisscross. Here's iron. Here's sulfide. Yep. Can you give me about 10 more minutes? Okay. What's the charge on sulfur from my periodic table? 2 negative. What's the charge on iron? Several. Which one do they want me to use? Why? How do I know they want me to use the 2? Because of the Roman numerals. Oh, this one crisscrosses quite nicely. It gives me a 2 and a 2, although I would reduce that to lowest terms. F-E-S. You know what? This one is balanced. The way I would mark this, by the way, is I would probably give you 1 mark for actually coming up with the correct formula, and then 2 marks for the balancing. Since it's balanced, you get 2 marks for writing balanced. Copper chloride yields copper plus chlorine. Well, copper I can get, that's Cu. Chlorine I can get, oh, Mr. Hofbrinkel, it's going to be Cl2. Copper 1 chloride, that I got a crisscross off in the margin. There's copper. There's chloride. What's the charge on chloride? Negative. What's the charge on copper? Several. Oh, wait a minute, no. Connor, they told me they want me to use... Oh, this crisscrosses quite nicely. This ends up being, as a formula, CuCl. Now, Rylan, I can balance. Is it 2 and 2? I think. Yeah. Is that okay, Allison? How many coppers on the left? How many on the right? How many chlorines on the left? 2, right? How many on the right with that little subscript there? Also 2. Okay, we're balanced. And 17 and 18, and then I'm going to give you another take-home quiz and kind of shut up and turn you loose. Pardon me? Oh, is there a 19? Okay, how about 17 and 19? There we go. Hydrogen, uh-oh, H2. Chlorine, uh-oh, Cl2. Hydrochloric acid, I told you last class, was HCl. Oh, just like that, right? So 1 mark for coming up with the formula, and then 2 marks for the balancing. Calcium oxide. Is calcium multivalent? Wait a minute, I didn't need to ask that. You know how I know calcium isn't multivalent? Because if it was, what would be sitting in between those 2 words? A Roman numeral. So, I need to get the formula though. I'll do it over here. Calcium, Ca is 2 plus. Oxygen is 2 minus. Oh, that crisscrosses quite nicely. It's going to be CaO plus water, I know, H2O, yields calcium hydroxide. So here's calcium hydroxide. That's from the back of my periodic table. That's a polyatomic. That one is OH negative, and this is 2 plus. When I crisscross, I'll end up with Ca, one of them, OH, 2 of them. Am I balanced? Don't think so. Nope, I'm not. Oh, am I? Wait a minute, I am. 1 Ca, 1 Ca. 2 H's, 2 H's. 1, 2 O's, 2 O's. I didn't notice that. I thought I was going to have to do some work, but this isn't as bad as I thought. How about number, Okay, number 19. Mercury 1 chloride. So that's going to be Hg1. Cl is negative 1. Oh, that's just going to be HgCl. Yields mercury plus mercury 2 chloride. Okay, HgCl, and they want me to use 2. Okay, when I crisscross, I'll get Hg1, I'm not going to write the 1, Cl2. Okay, how many Hg's on the left? 1. How many Cl's? 1. How many Hg's on the right? 2. How many Cl's on the right? 2. Oh! This balances just with a 2 there, I think. I think. Is that okay? So give yourself a pretend score if you want to out of 43. I'm not actually going to count this out of 43. I'll probably make it worth 20 marks, and if you tried every question, you get... How much were the questions, 1 to 14, 2 marks each? Okay. So for 28, and then 3 marks each. But really, Julia, all I'm going to do is give you credit for having tried every question. I'll probably make it worth 20 marks. Take-home quiz number 2. So just to remind you, you can work on all these last couple. Most of you still haven't handed in page 211. A lot of you haven't finished the section 4.3. There are some challenging questions in there. Don't wimp out and just copy the answers because I attached the answers. This class is also here for you to start picking my brain or ask your neighbors. We got kids that are getting the hang of this. This is great. So a week from today, first thing, you're going to hear me bellow out, get out your take-home quiz. We're going to mark it together. Chapter 4, vocabulary, you can work on that for the crossword. If you finished it already, great. I did put up the word list at the end of class, last class, right? And you all took a picture. Did I do that with you? Yep. So if you were away, I can show you that later. When is the test? Not next week, Wednesday, but the week after Wednesday, and I'll send an email out to that effect as well. Otherwise, you are working on section 4.3, balancing equations quiz. Okay?